My name is Ronan Kelley, and my group decided to do our project on the history of SSH, also known as Secure Shell. Secure Shell is a suite of programs used to remotely connect two computers together in a secure way, even over an unsecure network. The first part of SSH's history that we'd like to talk about is Telnet. Telnet was originally designed for ARPANET, which was the internet back when it was controlled mostly by the US military and various university installments, as a way to connect terminals together in a hardware-agnostic manner to save money. Originally, when you wanted to connect two devices together, you would have the main computer, and then connected to the computer, you would have a teleterminal, like you can see up in the top right here. A teleterminal was basically a keyboard, much like one that you might use today, connected to a typewriter. And instead of a screen, all of your console commands would be output onto this piece of paper that would continue to be moved and output to as you typed. Telnet was built on top of the Transmission Control Protocol, or TCP, which is the same system of sending and receiving packets that is used by pretty much the entire modern internet. HTTP is built on top of this, HTTPS is built on top of this, SSL, could go on and on. One of the big contributions that Telnet made was the Network Virtual Terminal standard. Back in the day, different terminals had different character sets. They mapped different characters to different numbers. We've used ASCII in this class. You're familiar with what is now the standard, but back in the day, there was no the standard, and everyone kind of did their own thing. The Network Virtual Terminal was a virtual device that the actual physical terminal could translate its character set to, send those characters over the network, and then from the network, they could be translated into the character set that the client or host, whichever side it was going to, actually understood. One of the really cool things that Telnet did was a future-proof connection negotiation scheme. When a client connects to a host, it asks the host what features it understands, and the host then sends back a list, and the two figure out what subset of features both understand and continue forward with just those features. This enabled different versions of host and client software to work together when they otherwise wouldn't have been able to, and ended up becoming a very standard practice going forward. But for the time, it was very, very forward-thinking and wasn't something you really saw anywhere else. It was also, of course, as was the original point, much cheaper than wiring together teleterminals to their matching hardware. Now you just needed to have a teleterminal and a computer, and you could hook them together regardless of what brand each one was from, and it was much simpler to set up. The big con, of course, is that Telnet only operated over plaintext. At this point, there were maybe a dozen computers networked together in the entire world, and there just wasn't an issue of security. Pretty much no one had access to these things, so who was going to be a nefarious actor? The other thing that became more of an issue, as again, we had more security and more people involved in computing, is that there was no concept of users or passwords or trusted hosts that we expect of modern remote connection services. We'll get to that more later, but effectively, Telnet just connected two computers together, and any kind of security was then left to whatever program was being run on the computer to do itself, which wasn't fantastic. The next precursor we'd like to talk about is called rlogin. It was first released with BSD 4.2, which, if you're not familiar with, is the open source distribution of Unix that was started by the University of California, Berkeley, and has since been turned into several other projects such as OpenBSD, FreeBSD, and another little project you may have heard of called macOS. Rlogin isn't really used that much anymore, but it retained most of the features of Telnet while introducing new ones, namely most of the things that I mentioned were lacking in Telnet. It knew about logins and passwords, it implemented trusted hosts, and it supported a very small amount of encrypted traffic. Let's talk about those last 2 points though. The trusted host system was implemented via IP matching, which is insecure because you can just spoof your IP. You don't have to report your real IP when you're interacting with something over the network, and that meant that if you set up an IP and said it was trusted, that was a trusted host, it can connect to my computer without any login and do whatever it wants, anyone could just go and change their IP to match that one, connect to your machine with it, and have complete control over everything. There also, again, was encrypted traffic, but it was only through a project called Kerberos, which is MIT's solution to networked encrypted certificates, which works well now. It didn't work as well back then, and it also, at the time of rlogin being at its peak, was very rarely available, right? If you weren't working in a university, you pretty much just didn't have access to it. Another big feature of rlogin was that it could forward Unix environment variables to the remote host. So that doesn't sound like anything meaningful if you don't use Unix-like system, but it did make it a lot easier to work in the shell, and it was nice to be able to take your environment with you when you went to, again, a remote host. Finally, it handled certain control characters better. So in a Linux terminal, or in this case a Unix terminal, you can input certain characters like Control-D or Control-C or Control-Z that do special things but don't actually correspond to that ASCII character. And in Telnet, a lot of those worked kind of weird. It was strictly raw mode, which means that it just sent every byte you sent one-to-one. Nothing was ever processed on the client side. rlogin introduced a cooked mode, which is where the client side will take your input and process some of it on your end. So if you typed in a command and realized that you wanted to backspace and fix the last character of it, before that would all be sent over the network and processed on the host side, but with cooked processing of input, you could have that be processed on the client side, which reduced the overall strain on the network and also helped to standardize things to the client instead of everything on the host. rlogin as a whole was standardized in September 1991 with RFC 1258, which was superseded almost immediately after in December of 1991 with RFC 1282. So with the precursors out of the way, we can finally talk about Secure Shell itself. It was designed by this Finnish guy, whose name I'm not going to butcher out of respect for his work, in 1995 after a password sniffing attack affected his university. It has a very rich feature set. It supports file transfer, both individual files and by encrypting FTP connections, which is the file transfer protocol, through SFTP. It supports arbitrary traffic through tunneling, which means that you can make an SSH connection between two computers and then take any traffic on the client or host and pipe it to the other computer over an encrypted connection. It supports X11 forwarding, which rlogin also supported, X11 being the graphics server for Unix-based operating systems until actually very recently. In the last 10 to 15 years, they've started to move to a new standard called Wayland. But for a very long time, X11 was the way to move graphics about. rlogin also supported X11 forwarding, but it did not automatically set up the display environment variable that X11 uses to determine the size and output of the display it's targeting. SSH also supports key-based logins. This means that instead of using a password once you've connected to the server, which is inherently insecure, you can generate a 256 plus byte key that will be used instead of a password, which not only allows for automatic login, because your key will automatically be pushed to the host you're connecting to by the SSH client, but it also makes it much more secure. If you have a password-based login, anyone on the internet, assuming you have your SSH server connected to the internet, can just keep sending passwords to it all day long. There are things you can do, like limiting the number of passwords that can be given in a certain period of time, but with how cheap it is to get a slave node or a huge mass of them, like are used in DDoS attacks, that's just not really a viable way of protecting your system. SSH also does trusted hosts, which again, rlogin did this, but the way that SSH does it is a lot more secure than rlogin. Instead of relying on the host's or client IP for a trusted host, it relies on the public key of the trusted host. This means that you can't spoof it like you could with IP or something like a MAC address, because if you were to give a fake public key, you wouldn't have the private key, and you couldn't actually complete the initial negotiation handshake, where the host sends a number that it has encrypted, and you have to decrypt it and then send it back. Speaking of encryption, SSH, of course, major advantage over everything else is that everything is completely encrypted from start to finish with a variety of encryption methods available. This includes very standard keys like RSA, as well as somewhat lesser known keys like ED25119, which are kind of up and coming in the world of security. The standard for SSH was originally drafted in 1995, or the first standard anyway, but it didn't become an official standard until January of 2006 with RFC 4250, and the next, I think, almost 10 RFCs after that, all relating to SSH. This is when it was assigned its port number of 22. This is when the file format for the known host file and for key files was established. This was when the Fingerprint format was established. Everything was happening in January 2006 and has been built upon since then, but that's when it all started. I've got this little datagram for how SSH works. I'm not going to explain it in detail. This is pretty much what we've been doing in class. The only real important detail of this is that to confirm who someone is, we send them a random message, have them encrypt it, and then we decrypt it with their public key to confirm that they are who they say they are. Anyone can give you any public key and say that it's theirs, but unless they are able to do encryption that can be decrypted with their public key, you don't know that that's really their public key. Finally, there are a couple of vendors for SSH, and I want to talk about that because I think there's some important things to know about not just the security of the software, but who is developing it and what implications that has on the security of the software. The main commercial vendor is SSH.com, which is actually run by the original designer of SSH. They distribute Tectia, which is a proprietary SSH suite that advertises mainly enterprise solutions and quantum-resistant encryption methods, which you ostensibly cannot get elsewhere, but in reality you kind of can. The OpenBSD project distributes OpenSSH under the BSD license, and PuTTY distributes PuTTY under the MIT license. The most common implementation by far, or at least most commonly used, is OpenSSH. Built into Windows since Windows 10. It's built into pretty much every Linux distribution by default. It's built into macOS, and it's built into most BSD distributions. The reason that it's so common is not just because it does a good job of implementing the SSH standard, but because having an open source tool for your encrypted communications means that you can audit it. And not just audit it, but anyone can look at how it works. And that way you know that it doesn't work because of obscurity. It's not that if someone figured out how it worked, they could just break through whatever you're doing, but it works because even if you know exactly how it is encrypting things and how the protocol works, you still can't break into someone's connection that you aren't supposed to be able to see.